Hello, physics fans. Welcome back. We're going to do example number 8 on the incline plane physics worksheet. Example number 8. So, first of all, it says a 6 kilogram mass slides up, so it's sliding up, so the coefficient of friction is 0.1, 45-degree ramp with an initial speed of 20 meters per second. Draw a force diagram and the gravity component triangle. Find the amount of squeeze and slide components. Find the normal force on the mass. Find the force of friction on the mass. And find the acceleration of the mass. Then find the time for it to stop. So it's going to eventually come up to a point a little bit higher. As it slides up, it'll stop when it gets up to a certain point. So, as you can see, I've already written things down, but let's do the force diagram first. There's our block, and it's on the surface, so there's a normal force, and there's a force of gravity. You can't change those. But it's sliding up, it's going up, so friction is going to oppose the motion. So there's a force of friction this way. There's our free body diagram. Now, the forces. There's a normal, and then there's the friction. And now the gravity in two ways is going to be that way for the y to hold it against the surface, and this way for the force of gravity to slow it down. It's actually pulling it down the slope. So gravity is slowing it down as well as friction is slowing it down. So they're working together for a change, gravity and friction, and that's the normal. So that's A. B, the amount of squeeze and slide component, it's just the formula. That's why I felt very comfortable zipping in and writing force of gravity in the x, mg sine theta, and writing down the numbers. And the calculator says 41.58. So that is 41.58 newtons. And then squeeze against the normal force will be this mg cosine theta, which is 6 times 9.8 times cosine of that. And it's the same thing because the sine and cosine of 45 is the same. So the normal is that as well. The normal is that. That's C. So that's how much force the cable is pushing up, or the surface is pushing up on the block mass. And the force of friction is mu times n, and mu is 0.1 times 41.58 newtons. So that's going to equal 4.158 newtons. Now find the acceleration of the mass. Well, we have to use Newton's second law. The sum of the forces equals F net equals ma. And it's accelerating this way. So we have to add those two together to equal the acceleration. It's the opposite direction of motion. It's a deceleration, if you want to talk in those terms. So that's pretty good. So the force of gravity in the x plus the frictional force is equal to ma. So, what happened there? My video is ready. My other video is ready. But let's go back. And take this plus 4.18, which is 10%. So this is, take this plus 10%, which is, I'll multiply that by 1.1. So it's 41.58 newtons. Oh, I'm leaning on the keyboard, that's why. 58 newtons plus 4.158 newtons is equal to, combination is 45.7, and this rounds up to a 4 newtons. I'm just holding my hand up in the air. Here we go. Equals MA, which is 6 times A. So divide this by 6, and that'll be your acceleration. Acceleration is equal to 7.623 meters per second squared down the slope. And F, the kinematics, the time to stop. So VI is negative 20, VF is equal to 0, and the acceleration is positive 7.623. So the time is going to equal VF minus VI all over A. So it's going to be 20 divided by 7.623. So 20 divided by that number above equals, it'll take 2.624 seconds. That's the answer for F. Sorry about that, but that's I started ahead, so it wasn't that long of a video. Take a snapshot of that, memorize it. It's on the final exam. Yeah. An actual interesting thing now is have it go down the slope. Once it stops, calculate how high it went. So that would be G. And then it starts to slide down. As it slides down, the frictional force switches over to the other side. So you now have them subtracting it. So you take these two numbers and subtract it. You get a new acceleration down the slope. And you take the time and the distance that you had to calculate and slide it down, and you get a new time for it to come down the slope, which will be longer. Interesting. And you see that. Anyways, we'll talk about that later. Great question. So now, where are we? Well, you're at the end of example 8. After that comes exercises, things to try, and there's answers. Not solutions, answers. 2 and 3. These are the answers for them. 9, 10, 11, 12, 13, 14. Oh, you have some time to work on these. Please get them done. See if there's any issues. Email me if there's any issues, and I will maybe do a few extra solutions of these up at the top, but I don't plan on doing solutions for every one of these. The answers are there. Good luck. Subscribe, like the video, leave your comments. Maybe you can even leave your comments down below. Thank you.